Got it. Okay, that's good to know. Okay, so let's continue with this chapter as of now. Okay, na?
Okay.
Later on, we'll be doing we'll be doing the chapter data handling also. All right, now you will
Okay.
get to learn about that as well.
Okay.
See, the chapter that is chapter number 3 in the NCERT book. You will find it as the chapter number 3. That is number play. So number play, it's kind of a fun way to explore and understand the numbers. Okay, na? We'll be exploring
Okay.
about numbers in this. We will discover some new patterns in the numbers. We will get to solve some puzzles, right now, and we'll be using the numbers creatively. In a creative manner, we are going to use the numbers. Like through some activities, you get to you will get to learn to compare the numbers, to arrange them in an order, to estimate the numbers, right now. So this chapter is basically aimed at improving your problem solving skills, your mental math, your logical thinking, right now. So it makes math enjoyable and practical in real life situation. Okay, now. And these are the topics we're going to be learning about. Okay, now these are the major topics we're going to be learning about in the chapter. Like numbers can tell us things. Okay, under that, you'll be learning about supercells. We'll be learning about patterns of number on the number line, playing with digits, estimation, and so many things. Right.
Okay.
So we see that numbers are everywhere and they help us understand the world around us now. Right. For example, your age tells the story of how many birthdays you have celebrated. Right.
11. Yes.
11. Good. Or the time on the clock tells us when it's time to eat, play, or study. Right. Now. So number gives
Yes.
us information and it makes life easier to manage. Getting it now?
Yes.
So number play a vital role in our daily life. They help us. They help us to organize and manage various tasks. Okay, when I'm going to sleep, when I'm going to eat, when I'm going to go to school, I'll be back to my home, right now. So will be so they are helpful in various ways, right now. So in different situations, they are helpful, like in telling time, in shopping. Numbers are used to calculate the total cost of the items, total weight of the items. So it helps us to manage the money. In cooking, so certain recipes often require a specific measurement of ingredients, right now, like 10 gram of this particular spice has to be used, right now. Getting it, 5 gram of salt has to be added, like that. Even in traveling, numbers help us to understand the difference between two cities, right now, the distance between the
Yes.
airport and your home, like that. Even in sports, numbers help us in calculating the score, the time limit, right now. In certain sport, there's a time limit. Under that time limit, that event has to be completed. So in everyday life situation, numbers are very much helpful, right? Also, we have used the numbers for counting as well as for performing basic operations like addition, subtraction, multiplication, division, and so on. Okay. So numbers can tell us different things. Imagine a scenario where students are lined up for a school race. There's a scenario where the students are lined up for a school race, and each student announces a number. Each student, they are announcing a number
Announcing.
which will represent something about their position in their line. Okay, na? So they have been lined up. Hold on. 1 minute, I need to put this into charge.
It's okay.
Yeah. Yeah, so the students are arranged in a line like this. Okay. Like that, let's say. Further, it mentions that each students are required to announce a specific number and that number will represent something. Let's say a student says 1 if there is one faster runner next to them. A student says 1 if there is one faster runner next to them. A student says 2. A student will say 2 if both the runners next to them are faster. Both the runners next to them are faster, like that. Getting it now? Or a
Yes.
student will say 0 if neither of the students next to them is faster. Like suppose there's a student, this student says 0, So he will say 0 when neither of the students next to him is faster than him. Getting it?
Yes.
That's some interesting thing to see. Okay,
Yes.
getting it. So far some of the basic things we have learned, right? Like how numbers can tell us different things. Your number can, your age tells the story of how many birthdays you have celebrated. Getting it now? Like that. Now
Yes.
we have the concept of supercell, right? So the concept of supercell can be understood as a cell that is larger than all its adjacent cells. Like for example, look at the numbers highlighted in the yellow color over here. So when you look at the
Yes.
number 92, so it is bigger than its adjacent numbers, no? Numbers on its side. Number on the side of 92 are 78 and 31. And it's greater than both of them now. So this would be a
Yes.
supercell, right? Then look at 45.
Yes.
So the adjacent number to 45 is, adjacent means
78.
right next, just next to something is called as adjacent, right now. So here, what will we say about 45? Will it be a adjacent? Will
Is
it be a supercell number?
no,
No,
because it is less than 78.
exactly. So supercell is a number in a grid that is larger than all of its neighboring numbers. Okay, now the neighbors of a cells are the numbers directly to the left, right, above, and below. Getting it now? Like we have a simple grid over here, then we can have a bit complex grid like this also.
Yes.
So here, let's say we have got 9, 1, 8, 3, 4, 5, 7, 8, 6, 2, 0, 1, 2, 83, 389, 4, 5, 6 is there, 7, 8, 0, 3, 4, 5. Like, let's say these are the numbers. We will try to highlight the supercell here. Right now, just moments ago we have learned supercell will be any number that will be greater than all its neighboring numbers, whether that number is
Yes.
to its left, right, up, or down. Okay. So what can you say about 918? Will it be a supercell?
Yes.
So let's highlight it. Okay, now it will be a supercell. Is there any other supercell in this that is possible?
Uh,
Mhm. What can we say about 345? Although
no.
it is bigger than 201 and 283, but the number just below it is even bigger than it, so it is not. What about 786?
786. No.
No. 389 or 456?
Both of them are not possible.
Not possible, no? Because right
Not
next to,
possible. Not.
exact hmm, right next to 456 we are having 780, which is bigger than 456, but even 780 is not a supercell because just above 780 we have got 918. Getting the concept of supercell right now?
Sorry.
You're getting the concept of supercell or not?
Yes.
You got it? Okay, good. Let me give you a few more questions based on this. Hold on.
Okay.
Let's say we have got numbers like 45, 62, 55, 31, and 82. Okay, which
Yes.
one of these, like how many of them are supercells?
62.
Hmm?
And does 82 count?
Exactly, it will be counted now, right?
Okay.
Even if the number is at the end, it will be counted if it happens to be bigger than its neighboring number. So 82 is bigger than 31, right? So that is
Yes.
simply the concept of supercell here. Now we have got some questions from NCERT. I hope you have already done
Yes.
these questions.
Yes. We've done it.
You have done it? Okay. So we will pick only few questions out of these. Okay, now since you have already done it, so we will
Yes.
pick only
Everything.
Uh-huh.
Everything we have done here.
Oh, you have done it. Okay.
Yes.
Was there any question which you found difficult to answer?
Uh, Not really.
Not really. Okay, okay. Okay, let's see. Let's do some of the questions. You will get to revise it
Okay.
once again. So
Okay.
look at question number 2. Like question number 1 is simpler. We are ignoring that. Fill the table below with only 4-digit numbers such that the supercells are exactly the colored cells. Like the position of the supercells should not change, but we have to fill all these cells with 4-digit numbers such that the position of supercells do not change. So what number should we write here?
Greater than 5,346.
Exactly. It could be any number. Say a number.
Yes. 8,294.
Very good. But right next to 8,294, we should write a
Uh,
smaller number.
Less. Yes,
Hmm.
less number than both 8,294 and 1,258.
So we must ensure that it's lesser than 1,258. So we can simply
Okay.
write like 1, 1, 1, and 2 like that. 11 and then 12, right?
Yes.
Okay,
Yes.
then
Uh, Beside 1,258, less
hmm.
number than that number. So
1039 we can write down this.
yes.
Okay, then
Uh, uh, any number
but it has to be greater than 1039. Okay, na?
greater than. Okay.
Hmm. Let's say we have written 1200. Okay, then we have,
Okay.
let's say, written 4000.
4,000.
But the number that we are going to fill in this cell should be bigger than this number.
9,600.
So what should we write? It has to be a 4-digit number.
Yeah.
Uh,
I wrote here 9,999.
Very good. So we have done this question. Okay. Now look at third question. Okay, na? So fill the table below such that we get as many supercells as possible. We have to use numbers between 100 and 1000. 100 and 1000. So we are trying here to fill as many supercells as possible here. The number should be between 100 and 1000. So what
Yes.
number should we start with?
Uh,
Hmm.
5,124.
5001. No, it should be between 100 to 1000 now.
Oh,
It
okay.
should not exceed that.
Okay.
Mhm.
948.
948. Okay,
48.
good. After this,
124.
124. Okay, you should rather take a smaller number. You should take a number just smaller than 948 or or bit closer to 948. Because if you were
Okay.
to take 124, it will seem to end quick. Okay, na? You may not be able to take much variation in it. Yeah.
Okay.
How about we take 900?
Okay.
Hmm.
Hmm.
So this number clearly will be the supercell as of now.
Supercell.
The next number we should take as
Uh, 999.
999. Okay, good. So
That will be our second supercell.
exactly. And after this, we have to take a smaller number. So tell me the number.
Yes. 847.
847. Good.
47. Yeah.
Hmm. Then
924.
924.
24.
Good.
Here.
Hmm.
798.
798. Good. After that,
Here. Uh,
we can.
9,000. No, sorry, 953.
Good.
That will be our fourth supercell.
Hmm.
And last. Uh, 648.
Good. After that,
784.
784. Very good. Okay, so we have taken numbers between 100 to 1000, and these are the maximum number of supercells. How many of them are there? Total of
5.
5. Very
5.
good. So in this, out of total 9 numbers, we have got 5 supercells. Okay.
Yes.
Then look at question number 5. That's an interesting question. It's saying find out how many supercells are possible for different number of cells. Like if we have taken, we have to at least begin with 2 cells now, right? So in 2 cells, one supercell is possible, right?
Sorry.
In 2 cells, there's possibility of one supercell or not. SS here is for supercell. Like you have taken 50 and you have taken 30. So 50 is a supercell, getting it?
No, I don't really understand.
Look, question number 5 here says that find out how many supercells are possible for different number of cells. Cell here is basically being referred to the boxes. Okay, so there
Yes.
are 2 boxes meaning 2 cells. So in 2 cells, there's possibility of only one supercell now. Out of the
Yes.
2, only one of the number could be bigger. Both can't be same. So in 2 cells, there's possibility of one supercell. Then if we were
Yes.
to have 3 supercells, three cells, I mean to say, then
Yes.
there's possibility of
Only 2.
only 2 now. Good.
Yes.
So let's say we have taken 50, 20, and then we have taken 30. So 3 cells, that is giving us how many? 2
2
supercells.
supercells.
Just like this, tell me what about the other numbers, other cells?
4 cells will give us 3 cells.
Hmm. Good.
5 cells will give us 4 supercells.
Hmm. So in this, we are finding out that the number of supercells are more than or half the number of cells. The pattern that we notice here, it tends to occur more frequently in the middle of the grid, where a cell has more neighboring cells to compare to. Getting it? So the
Yes.
number of maximum number of cells that can be there, okay, now, like it can be half of the cells or one more than half of the total number of cells. Getting what I'm trying to say?
Yes.
Okay, now. So that is some interesting pattern we are observing over here. Okay. Okay. Question number 6 here says that can you fill a supercell table without repeating numbers uh, such that there are no supercells? Why or why not? Okay, now whenever we are going to do any questions, now we will at least read the question twice. We'll first try to understand the question. Also, for question number 5, let me write down the statement here. Look,
Okay.
in question number 5, which we have just discussed, if let's say we are calling the number of cells as n, what are we calling it? Let's say, number of cells n, it's being represented by n. So when n is even, for n number of cells, if n is even, let's say for example here, what is the value of n?
Uh,
2,
2.
right? So n is even now. So if
Yes.
n is even, hold on, if n is even, then maximum possible supercells will be equal to n upon 2, n divided by 2. Getting what I'm saying? Like n was how much here? 2 now. So put the value
Yes.
2, 2 divided by 2, that gives you 1 supercell.
1.
And how many we had? 1 now.
1.
And then look at the second case in which if n is odd, so if n is odd, we are finding out the following pattern. So if n is odd, then maximum supercell possible will be equal to n plus 1 divided by 2. What's the value of n here?
And 3.
3. So we will put the value here 3 plus 1 upon 2, and that's going to give you how much?
It's for 2.
2, no? So we are having two supercells. Hope you have understood the pattern.
Yes, I've understood.
Very good. Okay. Then there are few more questions from the same concept. Question number 6 is, can you fill a supercell table without repeating numbers such that there are no supercells?
Oh.
Do you understand the question?
No, because actually, we didn't until question number 5. We've only written answers, but for 6 and 10, until 10, we haven't wrote anything. So our teacher did not tell us to do these questions.
Oh, okay. In that case, we can skip it, but still we should understand like what the question is saying. Okay, no?
Okay.
See, it says that can you fill a supercell table without repeating numbers, without repeating the numbers such that there are no supercells? Because the thing is now, it is not possible because there will always be at least one number that will be greater than its neighboring cells now, unless all the numbers are identical. What I mean to say here, look, suppose we are drawing a supercell table like this. Okay.
Okay.
Let's say we have made 1, 2, 3, 4, and 5 cells in this. So it's saying that can you fill this supercell table without repeating numbers, without repeating numbers such that there are no supercells? So it is no, it is not possible because there will always be at least one number that is greater than its neighboring number. Now, if I were to fill
Yes.
it, let's say I begin with 9, then I will be writing 8. Let's say I write 5, 10, 1. So here I'm saying that there is going to be some supercell. It's not possible that there will be there will there will be at least one number that is greater than its neighboring number now. But here there are multiple
Yes.
numbers that is greater than its neighboring number. Like 9 is greater, 10 is greater,
10.
right? Now, so we're having two supercells over here. Okay,
Yes.
that's the thing. Question number 7 again says, will the cell having the largest number in a table always be a supercell? That's an interesting question. It says, will the cell having the largest number in a table always be a supercell? Let's understand question number 7. Usually what have we learned, Hoja? That
We've learned
hmm,
about supercells. What was it?
that the number which is
Number.
largest will
Yeah.
be a
The
mhm.
Sorry.
The number that is large will be a supercell now, right?
Yes.
It has to be larger than its neighboring numbers so that it will be a supercell.
Yes.
But now the question says that will the cell having the largest number in a table always be a supercell? Let's understand this one. Let's say we have written some numbers over here. Okay, no? Let's say we have
Okay.
written some numbers here. I mean to say a table we have drawn here. Let us now try to fill it. Example, the numbers that we are going to fill over here. Mm, we can start it by some numbers. Let's say we have taken 200,
12.
not
Okay.
12, let's take some bigger number, 210.
Okay.
All right. Then we have taken 100, 430 we have taken. Okay.
Yes.
Then we have taken, hold on, 750. We have taken 640 over here. The question here says that, will the cell having the largest number in a table always be a supercell? The question says, will it always be a supercell? So actually, there will be some exception. There will be some exception where it will not be a supercell. Let's take another
Okay.
example. This one is not suitable.
Okay.
This question, the cell having the largest number. Yeah. So for this question, the largest number will not always be supercell. The largest number, it could be surrounded by other relatively larger numbers. Getting it? The largest number could
Yes.
be surrounded by other relatively large numbers, and if any of its numbers are larger or equal to it, then it won't qualify as a supercell. Getting it? So
Yes.
let's try to fill it. Let's try to have such a supercell.
Okay.
Say we have taken 100, 200, 800,
Oh,
150. Okay. And we have taken, let's say, 900. So in this, which are the supercells? Tell me.
200 and 900.
200 and 900 are the
900.
supercells. Good. Okay. Let's try to draw some more. Okay. Say some number.
250.
250. And
350.
350.
50.
Next.
319.
319. Okay. Next.
607.
607.
7.
Good. Next.
407.
407. Okay. So which are the supercells here?
350 and 607.
Right. So that is 350 and 607. Okay, no, 607. So far, what we can observe here, that it is not like, yes, the cell that is having the largest number in a table, looking at the option, it's always being a supercell, right now. But however, the
Yes.
cell with the smallest number will not always be a supercell. Getting it? Some cases
Yes.
we will get to learn that the cell having a small number, having the smallest number, can be a supercell. Having the second smallest number can be a supercell. Getting it?
Okay. Yes.
Question number 8 is very interesting. Look at question number 8.
Okay.
So it says to fill a number, fill a table such that the cell having the second largest number is not a supercell. Second largest number should not be a supercell. Let's try to do this one. Okay, now
Okay.
let's take some number here.
Okay.
Let's say the numbers which we have taken here are like 999. We have taken 980. After that, 943. That's 43. 850. 785 we have taken. We have taken 473. And now let's take 927. Okay. 846. 846. And then we will take one more number, that is 298. Okay.
Okay.
So question was asking us, fill a table such that the cell having the second largest number is not a supercell. Okay. Which is the second largest number in this?
Uh, 980.
980 is the second largest number. Good. So which are the supercells now? Tell me.
999.
Good.
Uh,
After this,
940. 900. No, 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 not 9.
what about
9.
927?
Yeah,
Mhm.
I was about to say that.
Okay, good.
900.
Right. So have we
Yes.
fulfilled the requirement of the question? Question
Yes.
was saying Euler table such that the cell having the second largest number is not a supercell. Second largest number is 980. Although,
Yes.
but even being a second largest number, it's not a supercell. So yes, it is possible. Then question number 10 is asking to make other variation of puzzle and challenge your classmates. So something that we can do, you can do yourself. Okay. Next topic is about the patterns of numbers on the number line. Okay. So
Okay.
here it says to put some of the numbers on the number line. The numbers are as follows. Okay. So like for
Yes.
example, the number 2180. Uh, so where is it going to lie between? It's going to lie between 2000 and 3000. And
Mm,
if you were to locate it more accurately, it will be lying between 2000 and
2000 and 2500.
exactly between 2000 and 2500. Very good. So that is where it is going to lie. Okay. So it's basically telling us about visualizing the position of numbers on a number line. Right now, it's quite simple thing. Further, we have the topic about playing with digits. So when we start counting numbers, we write them in order, no? 1, 2, 3, and so on in the ascending order, right? But other than
Yes.
that, are there some other different patterns also? Right, we'll be learning about that. Also, some basic things like the one-digit numbers. They are the numbers from 1 to 9, so they are nine one-digit number, right? So there are how many one-digit numbers? Nine one-digit numbers are there.
Yes. 1 to 9.
Exactly. Two-digit number, it ranges from 10 to 99. Now, if we have to
Yes.
find out like how many two digits number are there now, right? So thereby we will
Yes.
subtract the smallest two digit number 10 from the largest 99, from the largest two digit number, that is 99, and then it will add 1. So what we have done here, 99 minus
Okay.
10, right?
Equals 89.
89 plus 1, that gives you 90. So they are 92 digit numbers. How many?
92 digit numbers.
92 digit numbers. Similarly, if you have to find out like how many three digit numbers are there. So three digit number, it starts from 100 and ends at 999. So we will do the same thing. We will subtract 100 from it. From the biggest three digit number, we will subtract the smallest three digit number. Then we will add 1. So now we are getting 900. So there are 900 three digit numbers. Same thing we will do with the four digit numbers and five digit numbers and so on. So in this manner, we can find it out. Okay, now? In fact, there's a very important pattern here. There are nine one digit numbers, right? Then it increases to
Yes.
90. Then it increases to 903 three digit numbers, then 9,000, then 90,000, and so on. It will keep on increasing. Hope that is clear.
Yes,
Okay,
it's clear.
good. Then further, when we look at the digit sum of the numbers, okay, no? So here it's being
Yes.
said like this: a boy named as Rajat, he noticed an interesting pattern. Sometimes when you add the digit of different numbers, the sums are the same. Like you're adding 6 and 8, you have the number 68. When you're adding its digit, it gives you 14. 176, the sum of the digit is again 14, like that. So that is some interesting pattern here, right? Now it's an
Yes.
interesting pattern. So could there
Yep.
be few more numbers whose sum will be equal to 14,
Uh,
whose digit sum is going to be equal to 14?
10 plus 4.
10 plus 4?
Yes.
Not like that.
Oh, okay.
We have to take the number, let's say 59. Then 5 plus 9, that's giving you 14. Getting it? We're adding the
Yes.
digits. So like this, are there any other possibility?
Uh,
We can write down 590. So 5 plus
oh, yeah.
9 plus 0, that will also give 14,
Oh,
right? So
okay.
we can write down 590, 5,900, 50, 59,000, right? 59 lakh, 59 crore. Because no
Yes.
matter how many times you add 0, it's going to be
0 has
14.
no value.
Yeah, getting it.
Mm.
Other than that, What else can we have? Think of some more
6
numbers.
plus 6 plus 8 plus
It's
0.
it's already written over here. So you can take
Oh,
680.
okay.
If you were to take only
Uh,
2 digits or 3 digits only.
um, so 7 is 5 plus 7.
5 plus 7.
No,
No,
no, sorry. Uh,
you can say 257. So
257.
2 plus 5 plus 7. That's going to be equal to 14, isn't it?
Yes, yes,
Then you can give the number 167. So hence 1 plus 6 plus 7, that is going to give you 14. So like this, we can have many more patterns, right? So here it has been
yes,
done only for 14. So you can have the same pattern for numbers like 15, or for any other number you can have this pattern, right?
yes,
Okay, no? That's something. Okay, also we have exercise related to this. Will be doing that as well.
okay,
Okay. Then we have another topic, that is digit detectives. Okay, no?
yes.
Read this short paragraph, read this line.
Mahi had a curious thought. How often does the digit 7 appear when writing all the numbers from 1 to 100 or even 1 to 1000?
Hmm. Good. So here we are seeing that Mahi had a curious thought. How often does the digit 7 appear when we are writing the numbers from 1 to 100, or even if you're writing it from 1 to 1000? So how many times does the digit 7 appear? If, for example, if you have to write the numbers from 1 to 100, so the digit 7 will be appearing in which numbers? Like in the 7th, 17th, 27th,
27.
yeah, 37,
Yes,
47, 57, 67, and then from 70 to 79, total of 10 times, right? 70, 71, 72, 73, total of 10 times. Then 87, 97. So total how many times 7 is being repeated here?
20.
20 times now. 1, 2, 3, 4, 5, 6, 7. 7 plus 10, 17, right now? 17. Hold on. 1, 2, 3, 4, 5, 6, 7, 17, 18, and 19.
Yes.
There's something odd in it. Hold on. Have we missed some number here? 1, 2,
Uh,
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. They should be totaling to 19 actually. Okay, na?
oh,
They should actually be totaling to 19. Getting it now?
okay.
Similarly, we can calculate if now, but now the question is that if if we were to look at the digit 7, it will appear more frequently now in 3 digit positions, like between 1 to 1000. It will be appearing more number of times, right now.
Yes,
So thereby it will become difficult now if you have to keep on doing it in the same manner like this. It will take some amount of
yes,
time now.
yes.
Getting it? So calculating this for each position will involve counting how often 7 appears in each digits. Like for example, in the units place, okay, how many times the digit 7 is going to occur? Getting it? In
A
tens,
100 times.
100 times. In tens place, how many times it will occur?
Also another 100 times.
Right now? Getting it? Like
Yes.
7, 17, 27, right now? 27, 37,
37,
47,
40,
and then
30.
till 997. Got it now? Then at
Yes.
the 10th place, it's only possible when the number will start from 70, 71, 72, because 77 here is standing at the 10th place, as you know. So from
Yes.
70 till 79, getting it. Then for hundreds place again, it will be repeated for
A
100
100 times.
times, getting it. So here we have used a shortcut now to find the answer.
Yes.
So the digit 7 will appear 300 times between 1 and 1000. Clear?
Yes.
Okay. And the same pattern will follow for any other numbers, right?
Yes.
Good. Then we have another topic about the palindromic patterns, right? So palindromic numbers are the numbers that read the same forward and backward. Whether you read it from the left side or the right side, it's basically the same. Getting it? Basically reads the
Yes.
same. So look at some of the examples of the numbers here. Uh, can you quote some other examples other than these?
2 4 2
Good.
8 sorry 143.
Hmm.
What else?
Repeat.
5
141
55.
you said, no?
Yes.
Hmm.
55
555. Good.
and
There can be many, right?
yeah.
1331, 111, like that. So it's
Yes.
how can we create the 3-digit palindromes or 2-digit palindromes? Let's explore how to create all the possible 3-digit palindromes using the digits 1, 2, and 3. Okay, now using only these 3 digits, how many 3-digit palindromes can be created? So we have to use at least 2 different digits. Okay, now 2 different digits have
Yes.
to be used at the same time, and one of the digit can be repeated. So 121, the first and last digits are 1 and 1, and the middle digit is 2 here. Similarly, it will be 131, 212, 232, 313, and 323, like that. Getting it?
Yes.
So these are the all possible 3-digit palindromes that can be made using the digits 1, 2, and 3. Okay. Similarly, you can make some palindromes using the digits like 2, 3, and 4 also. Right now? Getting it?
Yes.
So how can we write down? 2, 3, 2,
3 2
right now.
3
Then
2
3, 2, 3,
3
good.
2 3
Hmm.
4 3 4
4, 3, 4,
and 3 4 3
3, 4, 3, right?
4 2 4
4, 2, 4,
2 4 2.
2, 4, 2, right? Any other
Yes.
possibility?
No.
No, that's it, right? Then look at some more interesting pattern here. In this one, what you're finding that you have written a digit, then you are reversing the digit and you're adding it. So you're getting a palindrome. See, right?
Yes.
Here again, here as well. Like 48 plus um,
84.
84, that gives you 132. Then we are
No.
reversing it once again. This one is not a palindrome, right? So here we are reversing it
Yes.
once again. So 132 plus 231, we got 363. Then 76 plus 67, it gives you 143. And then 143 plus 341, it gives you 484. So it's not possible every time, but in some cases, when a digit is added to its reverse, we are getting a palindrome. In some cases, right now. Hope you're understanding these important patterns. Okay.
Yes.
Right. So reverse and add method also gives you palindromes. For example, we pick 34, 34. The reversing after reversing the digits, it becomes 43, 34 plus 43, that gives you 77. Okay, now like that, we got some of the palindromes here. Okay. And the moment we have got a palindrome, you will stop there. Right now, because how can you reverse the digits of the palindrome and then add them? Like that's not practical, right?
It's not possible. Yeah.
Yeah, it's already a palindrome. Then we are now trying it with 89. So 89 plus 98, that gives you 187, not a palindrome. So we will continue again. So that's going to be 187 plus 781. That gives you 968. It's again not a palindrome. So we will keep on continuing right now. So
Yes.
968 plus 869, that gives you 1837. It's still not a palindrome. Okay, now.
Yes.
So in this case, you would keep repeating the process until you get a palindrome. Also, some numbers will take several steps to become a palindrome, while others might never reach one. Like you may get a palindrome here. In this case, you may get or you may not get. So some of the numbers will eventually give you a palindrome after repeated addition, but sometimes you may never get, no matter how many times you keep on repeating. Getting it? Okay, no?
Yes. Like
Hmm.
on the next page, 196 cannot be a palindrome.
Hmm.
Shows here.
Exactly.
Mm.
Okay.
Yes.
Okay, here's a fun puzzle given to you. I'm a 5-digit palindrome. I am an even number. My T digit, that is third digit, is half of my U digit, second digit. My H digit, that is the fourth digit, is triple my T digit. Who am I? Hmm? Says, who am I? So what could be the possible answer for this question? Think about it. Here it's
I
given.
wrote, yeah, I wrote here 12421.
1 to 4, 2, 1. So let's look
Yes.
at the question. It says that I'm a 5-digit palindrome. So obviously, whether you read it from the left or the right, it should be the same. And it says I'm an even number. So the digit at the unit place should either be 2, right? If it's an even number, should be 2, 4, 6, 8, or can be 0 also, right? Now, but it says my T digit, third digit, is half of my U digit. Let's begin with the smallest even number, that is 2, right? So my T digit, third digit, is half of my U digit. So say that this is 1, okay, no? It's half of my U digit. My H digit, that is the fourth digit. That's not the fourth digit, by the way. My H digit here is triple my T digit. It's triple my T digit.
3.
So
Should
it
be
will be
3.
3, right now. So that obviously from this side it's going to be 2 and 1. So 2, 1, 3, 1, 2 could be the answer. Got it or not? So that's the question.
Sorry?
You got this? You got the answer? You understood it?
Yes, I've understood.
Okay, good.
Should I write in my textbook?
Yeah, you can write it down.
Okay.
After this, we're going to learn about the Capricorn number. Have you heard of Capricorn number? Capricorn's constant?
Yes.
You have?
Yes.
Good.
6174. Yes.
6174. Very good. So 5-digit
Okay.
even palindrome number is given to you is 68,486 here. No, that's not the answer, by the way. That's a different one. Anyways, talking about this number over here, that is the Capricorn constant, the magic number of Capricorn. So Dr. Capricorn, he was a mathematics teacher from Devlali, Maharashtra. Okay, it's a place in Maharashtra. Who he had a deep love for numbers. Okay, he used to play with numbers. He used to explore the patterns of the numbers. So one day he discovered a very interesting pattern in the number that was never seen before. Okay, now so what he basically did, like suppose he had picked any 4-digit number. Okay, now say he had taken the number 6,382. Let's suppose then this number was arranged to form the largest possible number that was called as A, let's say. Then that was again arranged to get the smallest possible number. We were calling that as B, right? So now we subtracted B from A, meaning that 6,000, meaning that 2,368 is subtracted from 8,632. So that gave you 6,264. Then we'll again take this number and we are going to continue the same thing with this number,
Reverse it.
right? So
Yes.
we will be making it the largest number. We will make the smallest number out of it. We will subtract it. Right now we will subtract it. So eventually we will reach the number 6174. Right now we got 4176 earlier. Then we again arranged it to get the largest and the smallest number. We subtracted it. So we again got this number 6174. Now, what if we were to continue with the number 6174?
It will go on.
It will go on, but it will give you the same number basically. So that will be 6741 minus 1467, right? Largest and
Yeah.
smallest. Okay, tell me what answer you will get after subtracting it. Subtract it quickly.
Okay. I'll quickly do on my rough book 1 second.
Mhm.
It's 174
Yeah.
minus 4716. 14. I've gotten 1484.
How will you get that number? You're required to subtract it, no?
Yeah.
You're required to subtract it. There's some error in your subtraction.
Let me see.
Kaja, you will be getting the same number actually.
1 second.
Look.
I think I did something wrong. I'll redo it.
Okay, do it again.
1, 4.
Hey, Nafis, Laksh, how are you guys doing?
Good evening, sir. We are fine, sir.
Good evening, good evening. Yeah. Okay, so let's continue from where we have left. You guys turn your cameras on, Nafis and Laksh. So Kaja, after subtraction, you'll be getting the same number. 11 minus 7, that will be giving you 4, right? Then 13 minus 6, that gives you 7. Right now 6 minus 4. Yeah. After this, what number you're going to get? We have borrowed one from here. 6744, 41, I mean to say. Hold on, hold on.
Excuse
The
me, sir.
number you should be getting 7641 minus 1467. Here, look,
Yeah, you are right. It will be 6741.
6174 actually. When you will be subtracting 1467 from 7641, you should be getting this number. So if you are basically getting a constant number. It does not changes from here. So that is called as capital constant. Okay, no?
Okay.
Yeah, everyone here. Okay. So in the last class in the bash, we did the question. We completed some of the questions, right now. From the last exercise, some questions were left to do. Right, Laksh?
Sir, we are done with this slide.
Yeah, these things we were done with already. Okay, na? It was for Haja. Okay, na? It was for him. So we will do few questions from the exercise that is left. Okay, na? And as for you, Haja, see, these topics have been left, which we'll be doing in some of the class. All right.
Sir, is Khaja new in our batch?
Yeah, yeah. From today onwards, he'll be in the batch.
Okay.
Okay. Haja, let me just tell you, like some of the things that I'm leaving now, you will be doing it later on. Okay. like these topics right now, like the clock and calendar numbers. Okay. Then the patterns in the calendars, palindromic dates. Okay, reusing the calendars. These topics we are leaving as of now for you. We'll be doing it later on. All right. Let me quickly open the PDF. Hold on. Yeah, here we have the PDF. Okay. So guys, we have learned about the collapse conjunction in the last class. Remember, Yanafis?
Yes, sir. Yes, sir.
Okay, now we learned that if the number were to be like subtracted, I mean to say, if you were to start with any number, any integers, right now, say you have started with a, let me take the pen, hold on. Say that we have started with a even number, so we divide it by 2, right now. So we get the number 6 over here. Getting it? 6 is again an even number, so we again divided it by 2, so we got the number 3. So when we were getting the odd number, what were we doing? You were multiplying it by 3 and adding it 1. So 3 multiplied by 3 plus 1 gave you 10. So we had learned about the Collatz conjunction right now. Yeah, Khaja, tell me, you were saying something?
Sir, I've been in the class for since 5 o'clock. Do I leave?
No, actually, were you not notified that from today onwards you can continue in the batch? Will you be available for next 1 hour or not?
Sorry.
Will you be able to continue in this batch? Like this is the 6M1 batch. This is the
Okay,
maths
sir.
batch. Okay. Talk to your parents. Okay. So the last
Assalamualaikum, sir.
question. Yeah, walaikum salam, Habib. How are you? Habib, yeah, Habib, you had some doubts in your assignment. Okay. I will be needing you to send the assignment question to the counselor, so I get to know from which questions. Like I don't have the access to the assignment of
Yeah.
1st of August. Okay, now so just share the assignment with the counselor. Let him know so we can discuss the questions. Okay, now.
Okay.
Mhm. Yeah. So we were doing the questions from page number 72 in the last class. Okay. We were done with question number 1. Question number 2, we were done with this. Question number 3, from this number, we are going to continue. All right. All of you pay attention here. Look, Habib, turn your cameras on. So guys, the question says that, say we are the group of 5-digit numbers. It says we are the group of 5-digit numbers between 35,000 and 75,000. Okay. Such that all of our digits are odd. So we have to take only odd numbers, odd numbers between 35,000 and 75,000. Then further question is mentioning who is the largest number in our group, who is the smallest number in our group, and then who among us is the closest to 50,000. Okay, now see, we have written the number 35,000 here, and here we are having 75,000. Okay, first of all, which will be the smallest odd number over here? We have to take 4-digit numbers. It has to be odd, but which will be the smallest? Roger, you have raised your hand. You were saying something. You there or not?
Yes, my parents, my mother said that I can continue.
You can continue. Good. Yeah. So let me tell you some important things. See, right now, we are doing question from page number 72. In your school, were you done with these questions? Have you done these questions earlier? Open page 72.
72.
Mm-hmm. And
I
Habib,
need to check my notebook.
okay, check it. Habib, quickly share the assignment with the counselor so that I can discuss the questions in which you are having difficulty. Okay, now
Sir, I haven't finished my assignment.
you also haven't finished. You haven't finished it. Okay, make sure you finish it after the class, Nafis. Do you have some questions?
Yes, sir.
You also have. Okay, can you let me know about the question number quickly?
Okay, sir.
Nafis, sorry, Laksh, if you also happen to have any questions, you can also let me know from your assignment.
No, sir.
Okay. By the way, guys, we'll be keeping the assignment discussion at the last of the class. Okay. In the last 15-20 minutes, we'll be doing that. Okay. Now. Hmm. So, question number 3 here, we are doing this one over here. So, the smallest number in the group, that will be the what? Odd number will be how, what? So, will it be 35,000? Hold on. 001. Yeah. Can we take this number?
Yes, sir.
No, we cannot take this number. Because if we were to read the question carefully, all of you pay attention here. Stop doing whatever you guys are doing. Pay attention here. Read the question carefully. It says we are the group of 5-digit numbers between 35,000 and 75,000 such that all of our
Sir,
digits are
can we
odd.
get the largest one, 75,999?
That will be greater than 75,000. No, we have to take between 35,000 and 75,000.
73. The largest number in the group will be 70. If it is odd, then it will be 73,999.
Well done. That will be it. Okay, Kaja, are you saying something, Kaja? You have raised your hand.
Sir, in the what you showed me in page number 72, we've
Hmm.
completed until question number 10 in our notebook.
Okay, good, good. Okay. Anyways, you also pay attention here. Okay, now.
Sir, the smallest number will be 35,111.
Exactly. Why so? Because everyone look at the question here. It says all of our digits are odd now. But here, all the digits like they are not suitable here now. The odd digits starts from where? The odd numbers, where does it start from? Starts from
One.
one, no? One, very good. 1, 3, 5, 7, like that. So we will change these two zeros to 1. So 35111. 35,111. It's the smallest number according to the question here. It's the smallest number having
Odd.
all the odd digits in it.
Yes.
Then the
And the
largest
largest
number. Mhm.
73,999.
Exactly. 73,999. Why cannot we take 74,999?
Because 4 is even.
4 is even now, right? It's even number. But the question says all the dates should be odd, so hence it cannot be taken. So these are your answers. Hope it should be clear to everyone. Then it's saying which number will be closest to 50,000. Yeah, Habib? Anyone?
Okay. Yeah, then 50. No.
Mm-hmm.
Yeah, 51,111.
Brilliant. 51,111 will be the closest number to 50,000, having all its digit as odd numbers. Right now? Got it now? Why cannot I take it 53,111? Why I can't take it? Because
Because it is too far. And there
it's
is already one number before it.
exactly, it's farther than 50,000, but this one is closer. So these are your answers to the question over here. Hold on. 35,111 is smallest, this one is largest, and this one is the closest to 50,000. Okay, look at the next question. Question number 4 here says that estimate the number of holidays you get in a year, including weekends, festivals, and vacation. Then try to get an exact number and see how close your estimate is. Okay, now. Question number, should I clean this?
Sir, around 80 days.
Give me a minute. I just need to. Around 80 days, you're saying? No, it should be
Oh,
more
wait.
than that. Oh, no, it should be
Oh,
more
what?
than that.
Including festivals and vacation, then it will be around 100.
Yeah. No, no, even more than 100. It can be more than 100. Everyone look at question number 4 as of now. So estimate the number of holidays you get in a year, including weekend, festival, and vacation. Then try to get an exact number and see how close your estimate is. Okay. So,
113.
mhm. Hold on. We will move in a stepwise manner. Okay, now. First of all, tell me how many weeks are there in a year?
4.
In a year,
Oh, sorry, in a year, then it's 50,
52
50,
weeks.
52, 52.
There are 52 weeks in an year. Okay, now. Then we have got holidays on Sundays, right? Usually, let's say we have holidays on Sunday. It may vary from place to place. Some in some country, some places it's like
Yeah, like
Sunday,
Saudi Arabia has
Saturday,
Friday and Saturday.
Friday, and Saturday. Let's say we are counting Sunday as holiday. So how many Sundays are there? 52 Sundays as holiday, right, Khaja? Getting it, everyone? Okay.
Yes, sir.
Then there will be holidays on Saturdays also, no? Saturdays,
Yes, so
not
52
all the
more.
Saturdays. Two holidays, two holidays per month for Saturday. Getting it?
Yes, per month. Huh?
Holidays on Saturdays. I mean to say,
52.
no, no, no. Two holidays per month.
Two
Two
holidays per month.
two holidays for Saturdays per month. In many places, we have like the first and the last Saturdays are holiday. Okay. So two holidays per month, meaning in 12 months, that will be 12 times 2, that will be 24 now. Yes or no?
Over here, it's 52 only.
Oh, over there, it's 52. We can take that also. Let's say we are taking this value. Then talking about the summer vacation. How long is the summer vacation in your school?
2 months.
2 months. Okay, let's say. And what about others?
Sir,
Yeah,
I sent it to the counselor that my
you have
assignment.
shared it.
Yeah.
Okay, good. Okay, I haven't got it yet, by the way. I will be getting it in a minute. Okay. Huh.
So, a total of
As
62 days.
62. Let's say we are taking a rough number of 60 days only. Okay, now?
Sir, because it's July and August. So, 31, 31, 62.
Uh,
Sir,
let's say we are taking
86.
a rough number close to 60. Yeah.
86.
86. Okay. We can stick with only one number.
Uh,
Okay.
Winter vacation of 15 days.
15 days. Yeah. Winter vacation is not very long right now. It's short. So thereby, the actual number of holidays in the entire year will be the sum of all these, right? That's going to be how much? 52 plus 52 plus 24 and then 60 and then 15. Okay.
Sir,
Tell me
why
how
did
much
you
is going
write
to
52 twice?
52
Twice.
twice.
Yes.
I'm saying number of. Oh, sorry.
Yes,
My
there
bad.
is only
My
one.
bad. My bad. We have to take only this now. This 52, 24, 60, and 15. Yeah. My bad. So we'll be taking 52 plus 52 plus 24 plus 60 plus 15. Yeah, that's going to be how much? Tell me.
Sir, 145. 145.
145 you are getting.
Yes.
Okay, what about others? Earlier, what was your estimate? Earlier, what was your estimated holiday?
Sir, 151.
Hmm. By the way, we'll get back to this calculation in a minute. Okay, we'll get back to this right now. Earlier, what was your
151.
estimated holiday? Someone was saying 120, someone was saying 150, right?
Sir, sir, yes, sir, it's 151.
But here we are getting 151 right now. So this is the actual number of the holiday we are getting, right? And this was the estimated holiday that we are getting, that was 120 days, while this is the actual holiday we are getting over here. Getting it? Okay, question
Yes.
number 5. So estimate the number of liters a mug, a bucket, and an overhead tank can hold. Okay, na? An overhead tank can hold. Yeah,
What's a overhead tank? Like the tank used for
overhead
individual
tank.
building?
Uh-huh. Overhead
Like
tank basically. Mhm.
the one used for normal buildings or the one on the trucks?
No, no, the one that is used in the building, in the top of the one that is put in the top of the building that holds the underground water in it. Basically, like we using the motor pump, we take the underground water and store in it. So
Okay.
that's the overhead tank. Yeah.
A mug
Okay.
can hold 1.5 liters.
Yeah, it can. Let's say. Should I change the slide now? Should I change the page? Someone is writing it down now. If not, I will be changing it then. Okay.
A bucket.
Question number 5. Sorry. Question number 5. First of all, tell me an estimate.
Estimate of a mug is 1 liter.
Total how much? Let's say estimated number of liter of the mug,
Total
a bucket, and an overhead tank will be equal to how much roughly?
to 3,501.
Maybe 1000 liters.
You're saying 1000 liter. Okay.
Oh,
What about
I'm
others?
taking
Like 1 cubic
3,000,
per 1000 liters.
Okay. Anyone else?
3,016
3000.
liters. 16.
3016 you are saying.
Yeah.
3016 liter you are saying. Someone is saying 1000 liter. Raja, what about you? Habib, what about you? You guys also give some estimated number. Let's call it 1500 liter. Someone
1500.
let's say 1100 liter. So we have different numbers here. Okay. Now we will calculate the actual number. Okay, now. By the way, here it has not been asked us to calculate the actual number. Okay, now. But still, let's try to understand which one is the closest estimate here. Out of all this, which one is going to be the closest estimate? Okay, now.
Okay.
Okay. If you were to estimate for the mug,
1 liter.
1 liter. Good. Okay. A bucket,
A bucket around 15 liters.
let's say 20 liter
20
or 15
liters.
liter, 20 liter,
Yeah.
let's say.
Yeah.
An
At
overhead
least
tank,
2,000.
Overhead tank, maybe
At least
1000
2,000
liters,
liters.
like that.
but usually the mid-size tank is roughly of 1000 liter. Okay, now 2000 liter tanks are also available, but most common is the 1000 liter tank. So here it's more close to 1100 liter, right? 1000 plus 21, 121, 1021. Getting it now? So roughly around 1100 liter is the estimated capacity. Getting it, everyone? Yes, any questions? Yeah. Look at question number 6 then. So question number 6 is saying is Write one 5-digit number and two 3-digit number such that their sum is 18,670. Okay.
Two 3-digit numbers.
Hmm. So we have to take one 5-digit number plus two 3-digit numbers, two 3-digit number, such that the sum of all these numbers is exactly equal to how much as per the question? 18,000.
18,670.
Exactly. So
Sir, can I
let's,
tell?
okay, tell me.
For 5-digit, I'm taking 18,000.
For 5-digit, you are taking 18,000. Okay.
Yeah, 18,000 plus.
Everyone have to answer. The answers can vary. Your answer could be different. Nafis answer could be different. Khaj's answer could be different, or Habib's answer could be different.
70, sorry, not 70, 170,
Okay.
and 170 minus 670 equals to 500.
And 500. Brilliant. Very good. That is correct now. Okay. You guys also quotes give similar answers. Give answer to this question. Also, you can check your answer also by after adding all of this, you'll be getting the same answer. That is 18,670. Yeah. Nafis, give a number. It's simple by the way. Like you can take
800.
800. So that's a 3-digit number you have taken. Then
So 200.
200. Okay. So 800 plus 200, that is equal to 1000, right? This is equal to 1000. So how much more should we add to 1000 so that it becomes 18,670? Yeah. Anyone else who would like to fill the blank here? 800 and
17,670.
brilliant. Very good. Right. In this manner, we can get the answer. Very good. Okay. You guys also answered it. Yeah. Hojo, you also give the answer. Ibrahim, yeah, sorry, Habib, you also give an answer to this question. Meanwhile, you guys look at question number 7, those who have already answered it. Roger, am I audible to you or not? I am, no?
Sir, but I can't hear you clearly.
Okay, what about others? Lux, can you hear me?
Sir,
Habib?
yes, sir, I can clearly hear you, but there are a few like minor pauses, like suddenly.
Hold on. I'm resharing my screen. Okay, if the issue once again, if the issue repeats, let me know. Okay, no? Yeah, Khaja, you have raised your hand. Tell me.
Sir, for question 6, our school has made it like shorter. We've did in a different way.
For question number 5.
Question number 6.
Okay. What were the numbers which you got?
Sorry,
What were the numbers that you have got?
18,670 I got.
No, what are the 3 different numbers which you have got? Like you have to write down the number 18,670 as the sum of one 5-digit number and two 3-digit numbers. So just Mhm.
Doesn't show here. We've wrote 5-digit number is 18,000. 3-digit number is 3 uh 300 and 370, 180, 100 and sorry 1800,000 plus 300 plus 370 equals 18,670 is what I've wrote.
Good. So that is correct. Good. Okay, moving on to question number 7 here. Look, question number 7 says you have to choose a number between 210 and 390. Okay, that's for question number 7. Create a number pattern similar to those shown in section 3.9 that will sum up to this number. That will sum up to this number. So where is the section 3.9? Let's look at the section 3.9 here. Okay, that's section 3.9. Okay, that's section 3.9. So the question was asking us to choose a number between 210 and 390. All right. Then we were required to create a number pattern similar to those shown in the section 3.9 over here. Like some of the patterns have been shown here. Now these are the different patterns shown in section 3.9, right? That's section 3.9. Okay. So let's try to do this one. Ultimately, getting back to the question now. First of all, we will make a box like this. Okay. Then we will choose any number between it. Okay. Pick a number between 210 and 390.
320.
320. Okay. So we have picked the number. Chosen number is 320. Good. Now this number 320, if you were to observe the pattern in the section 3.9 here, see there will be some of all these numbers now. Right now there will be sum of all these numbers. Getting it? It will be something like how many 40s are there? 1 2 3 4 5 6 7 8 19 11 12. So 12 times 40 is equal to 480, right? And there should be 10 50s here. 1 2 3 4 5 6 7 8 9 and 10. So 10 times 50, that's equal to 500. So 500 plus 480, that is equal to 980 now. Getting it, everyone? Clear? See, these are the 40s here, right? How many 40s are? 12 40s were there, right? How many 50s were there? 10 50s were there,
10 50, yeah.
right? As I have highlighted it. So 12 40s, 480, 10 50s, 500. So total it's 980. Okay, now all of you turn your cameras on. So same thing we are going to do with the number 320, but we will divide it. Okay, now we will try to divide it. Getting it? What can we do?
We can use 10s and 20s. Like, for example, we can write 11 10s and 105 20s, and then the sum will add up to 220.
We can do that. Okay, now let's say that the number we are going to do divide it with the number. I mean to say we are going to break it in terms of 10 and 20. Okay, now. So in case of 10, we are going to break it in the following manner. Right now, we're going to break it in the following manner. So that's going to be 4 times 8 times 10. That is going to give us 320. That is going to give us 320. So thereby, what does it mean? Meaning that it basically means that we are going to split the given table here in such a manner that when we'll be splitting it now, so there will be, or we can simplify it also further. Like we can simply take 32 times 10. 32 times 10. So we will make total of 10 divisions in it. How many? Total of 10 divisions will be made in it. Getting it? And each cell here, each box will be equal to 32. So 32 times 10 will be giving you 320. Getting it? But we will try to break it into two parts. We will try to break it into two parts. Okay. So let's say that, hold on, give me just a minute so that I draw it. Okay. We will try to break it in terms of 10 and then 20. In case of 20. Okay. Let's say that there will be, there is equal to 22 times 10 equals to 220. What more should be added to 220 to get 320? 100, no? The 25, 20 times 5, that will be equal to 100. So we are going to break this in such a manner that there will be 22 boxes, each having the value of 10, and there will be 20 boxes having the value of 5 here. Getting what I'm trying to say? Or rather, we are going to break it, make it 5 boxes, each having the value of 20. We can do that as well. Okay. So in total, how many boxes are going to be in it? It has to be a even number, by the way, right? Total number of boxes that will be there should be an even number. So let us make it
Let's say
Yes.
42. Wait.
not 42. No,
Yeah.
not 42. That will not be practical. So since the number is 320 now, right? How about we break it into 40 pieces, right? How about we break it down into 40 equal boxes? Out of the 40 boxes, what we can do now, we will take 20 boxes, then we will take another 20 boxes. These 20 boxes, okay, these 20 boxes, each of them will have the value 5. So 20 times 5 will be equal to 100. Okay, how much is left? 220, right? So another 20 box that we are going to take, each of them will have a value of 11. So 20 times 11 will be giving you 220. 220 plus 100, that is going to give you 320. Is it clear what I'm trying to say?
So can you please repeat it again?
Sure. What I'm saying that the number given to us is 320, right?
Yeah.
We are going to basically split this into total of 40 boxes like this. We'll try to split into total of 40 boxes, let's suppose, right? In this 20 boxes will be such that, like, here will be 11, 11, 11 like this. Like this, there should be total of 20 boxes that will be equal to 220. Getting what I'm trying to say?
Yeah.
Okay, no. So that means 20 multiplied by 11 will be equal to 220. Then we will take another 20 boxes. Each one of them will having a value of 5 like this. 5, 5, 5. Like this, there should be total of 20. So 20 times 5 will be equal to 100, and hence total will be equal to 320. Yeah, Khaja, you are saying something.
Sir, I have to leave for my Quran class soon.
Okay, okay. You can leave the class then.
Okay, thank you, sir.
Yes, you're welcome. So that was question number 7. This you guys will try to do at home. Okay, now. Hope you guys have understood how it has to be done. Any questions?
No, sir.
Nafis and Habib, what about you? Habib, keep your camera on. Your camera is off. Let me quickly explain question number 8, 9, and 10. Then we are going to I will be taking up your doubts. Question number 8 says, recall the sequence of powers of 2 from chapter 1, table 1. Why is the Collat's conjecture correct for all the starting numbers in this sequence? The sequence. So it's saying us to move to the chapter number 1, table 1. If you have your NCERT book in front of you, you can quickly open it. Yeah. You guys open the chapter 1 from your NCERT book. Those of you who are having it, open it. And there's a table given in the chapter 1. It's talking about obviously the first chapter, that is patterns in mathematics. Okay. So recall the sequence of powers of 2 from chapter 1. So haven't we learned about powers of 2? You guys remember it? Powers of 2,
Yes.
powers of 3, right now,
Yes.
like 1 to the power 2, 2 to the power 2, 3 to the power 2, 4 to the power 2. So that is equal to 1 multiplied by 1, 2 times 2, 3 times 3, and 4 times 4. So that was giving us 1, 4, 9, 16, like that. So a table must be given there. Okay, now you may find it in the page number of the second or third, I guess. Okay, now the first table should be there in the third page, I believe. Second or third page, you can check it. So question here says that why is the Collat's conjecture correct for all the starting numbers in this sequence? What have we learned about the Collat's conjecture? You guys remember that now? If you have an odd number, if you have an odd number, right? Or if you have an even number, what do we do to that? Have you guys opened the table? Yeah. Nafis, open the chapter number 1, page number 3, you will find a table over there. There square numbers should be written. Okay, na? So why is the Collat's conjecture correct for all the starting numbers in that sequence? Right? So the sequence here is what? 1, 4, 9, 16, 25, 36. That will be the sequence, right, Laksh? These are the square of the consecutive natural numbers.
Yes.
Okay, no? So powers of the 2 sequence. If suppose we have to take continue from the powers of 2 sequence. Let me change the color. Hmm. So if you have to take the powers of the two consequences, two sequence, so they are 1, 4, 9, 16, 25, 36. Then after this will be getting 64 and so on, right? So power of 2 sequence here. Suppose we have to take power of 2 sequence. So 2 times 2, that gives you 4. All right. Then we are saying the numbers which you are going to get over here is, let's say, 4 times 4, that is giving us 6. Sorry, 3 times 3, that gives us 9. 4 times 4, that's 16. 5 times 5, 25, and so on. What we have learned about the Collat's conjecture, suppose if you were to begin with a even number, let's say we have 2. So what do we do to the even number? We subtract it. I mean to say we divide it by 2 now. So it becomes 1,
Yes, sir.
right? It becomes 1. Then if we have a odd number, we multiply it by 3 and add 1. So we get a even number. We have got even number here. Then when we get a even number, we again divide it by 2. Then we are getting 2.
Divided. Yeah.
Then 2 multiplied by 3 plus 1, that gives you 7 right now. So question was saying why, hold on, why is the Collat's conjecture correct for all the starting numbers in this sequence, in that sequence? For that purpose now, let me share the table from the book. Hold on. Here it's not getting clear. Let me get the PDF. Perimeter and area. Give me a minute. Let me open the PDF. Hold on. Give me a minute. I'll be putting the screenshot of that in the chat box. So can everyone look at the table? Okay. Give me one more minute. Actually, it will be irrelevant unless I don't share the screenshot. You guys won't get it because the question mentions about the table 1 from the chapter 1. Okay, I have shared it. It's still going on. It's still going. Yeah. Open that screenshot. Open the screenshot. Every one of you open the screenshot. And from that, look at the powers of 2. Look at the powers of 2.
Hear you.
Hold on. Am I audible? My mic is working perfectly. Look, can you hear me?
I can hear you.
Sir, I can't hear you properly.
What's it?
Can you guys hear me now or not?
Yes,
Abhi,
yes.
you can? From that table, look at the powers of 2. The powers of 2 are what? 1, 2, 4, 8, 16, 32, and 64. These are the powers of 2 given over there, na, right?
Yes.
Right? Okay. Now, are they following the Collatz conjecture?
Um,
They are
one.
following or not?
Yes.
Okay. So it says, why is the Collatz conjecture correct for all the starting numbers in this sequence? So in the starting numbers, it is
All the numbers are already like divided by 2, like 64, 32, 16, 8, 4, 2, 1.
exactly no. Because when we are having the odd or even numbers in the Collatz conjecture, they are divided by 2, and here all of them are divided now. Getting it? So thereby they are correct. Right? And going from this side, they are particularly correct here. 64 divided by 2 give you 32. 32 divided by 2 gave you 16. Divided by 2 gave you 8, and so on. Right? So from this side, it is correct. Question number 9 says, check if the Collatz conjecture holds for the starting number 100 or not. For the starting number 100 or not. So let's say we have taken the starting number as 100 in the same one. 100. Okay, now after 100, what will be the next number? We're talking about the
50,
power. Mhm.
uh, 50 for the collect conjecture here.
No, no, see. 1 square equals to 1, 2 square equals to 4, 3 square equals to 9, 4 square equals to 16. Okay, getting it.
Hundreds are ones, tens, hundred, thousand, 10,000, 1 lakh.
Mm-hmm. Hold on. Yeah. So we are having 16, 16 to 32, 32 to 64. So it's saying over here, check if the Collatz conjecture holds for the starting number 100 or not. So let's say we begin with 100. After 100, what number will be having?
50,
50. Then
25,
25. After 25,
Wait, 25.
75 plus 1, that will be 76. 25 is a
76.
odd number, na? So you're multiplying it by 3. Okay, na? 25 into 3 plus 7. But you know, that is not the appropriate manner to solve that question. That is not correct. The question here is saying something else. So first you have taken 100. After 100, 100 divided by 2 will be giving you 50. 50 is an even number. 50 divided by 2 will be giving you 25. It's a
25.
odd number, so 25 times 3 plus 1, that is 76. After
76.
76 will be having 38.
38.
19. After 19 will be having 58, no?
19.
19 3s are 57 plus 158. Getting it now? So ultimately, when we will continue now, you have to find out whether you reach 1 or not. You have to find out whether you reach 1 or not. If you reach 1, so yes, the collapse conjecture will hold true for the starting number of 100. If you reach 1. So this I am leaving for you guys. You will try to do it yourself. Okay now?
Okay.
Look at question number 10 now. Starting with 0, players alternate adding numbers between 1 and 3. The first person to reach 22 wins. What is the winning strategy now? Okay now? So starting with 0, players alternate adding numbers between 1 and 3. Like the players will be alternatively add number between 1 to 3. Okay, and the first person to reach 22 wins. So start by adding 3. So 0 plus 3 gives you
3.
3, right? Next,
3 plus
3
3.
3 plus, but we can take between 1 to 3. Okay now?
And then 1.
So start by adding 3 on your first turn to reach 3. Then always move in such a way that you leave the opponent on a multiple of 4. Getting it?
Yes.
You will always leave your opponent on a multiple of 4. Then following this strategy, we will be able to ensure that you will be able to reach 22 first, and hence will be able to secure the win. Okay now? Try to do these questions which I'm leaving. I'll be giving this as assignment. If you guys will face any difficulty, we'll be discussing that in the class. Now you
Are you
guys
gonna give it?
quickly yeah.
Are you gonna give that today?
Yeah, it will be given today. Okay.
Sir, I have a question.
Tell me.
What is infinity minus infinity?
What is infinity minus infinity? See, that is impractical. Okay now? Infinity cannot be subtracted from infinity. Getting it now? Like infinity is not some number, so we cannot manipulate it, we cannot do any operation on it now. Getting it? So infinity and infinity cannot be subtracted. It will be undefined. Infinity minus infinity, that is basically undefined. We cannot define it. It's not a valid operation because neither this infinity is number, neither this infinity is number. So how can we do any calculation? Although it might be tempting to think that it may be 0, but the result will be indeterminate. Like you cannot define it. Got it?
Yes.
Uh, okay, now you guys quickly tell me your doubts. I still haven't got you. Hold on, Habib. I need to text them. Mm, mm. Meanwhile, Nafis, you tell me that you got.
Yes, sir.
Nafis, you were also having some doubt. Now tell me quickly.
Yes, sir.
You were having some doubts in your assignment. You tell me.
Sir, I never said that.
Oh, you said in the beginning, I think.
I never had a doubt.
Oh, okay, okay. Yeah, now they're sharing me. Hold on. The questions that have been left, that will be given as assignment. Okay, if you guys will have any difficulty, we'll be doing that in the next class. And most likely in the next class, um, either we'll be starting a new chapter or we will do some revision. And now I have got it. Yeah. So what were the questions from this? Okay, there are total of how many? 1, 2, 3, 4 PDFs. Okay. From the topic lines and angles, Habib, tell me which question you found difficult and which one you are having a doubt.
I sent to the counselor.
You have.
Hasn't she sent you?
Let me check that. You have shared the PDF. Just give me 1 minute. Yep. Question number 24, you are saying. 24, 27, and 30. Hold on. 24, 27, 30. Here the question numbers are marked differently. 1 minute. Could you please read the question? Actually, the numbering of the question which you have shared and the numbering in the PDF is different. Like in the PDF, questions are marked as question number 1, 2, 3, or 4, like that. You will never have questions named marked as 24, 27, or 30 in the assignment PDF, right? Please read the question quickly so I can find it in the PDF.
Wait, I will bring my phone.
Okay. When is your school going to reopen, Laksh?
Sir, on August 25. Mama.
25th of August, okay. And Nafis, what about you?
It's gonna open at 25th.
Okay. Habib, hurry up.
Sir, I couldn't hear you.
There seems to be some network issue from your side today, I guess.
No, sir, but I just can't hear you properly.
I don't know what's the issue, but from my side, my connection is stable, like it's perfectly fine. Yeah, Habib, you got it? Yeah, Habib. If you guys also happen to have any doubts, let me know. Habib, we are almost out of time. Like we don't have much time left. Hurry up.
Yeah.
Yeah, tell me.
Question number 1. Draw all the diagonals of the given polygon. How many diagonals are there in total?
Okay, that is from the chapter lines and angles, I believe. Right?
Yes.
Just look over here. That was the figure given to you. Everyone pay attention to this. Many of you got the answer to this question wrong. These are the vertex, right? These are the vertex of it now. Right, Habib?
Yes.
So whenever we have to draw the diagonals now, what basically we have to do, we have to connect all the vertex together, right? So this vertex will be connected to this, right? This will be connected to this.
My test tomorrow.
You can repeat again.
Sir, can I send my test
So you drew it
tomorrow?
wrong.
Yeah, it's not very accurate. All of them should be, I mean to say, they should be meeting at a point here at the center. But try to understand it. Okay, now
No, that's not the part. It's
repeat it.
total 9 sides. You have drawn 8 sides.
Let me check it again. 1, 2, 3, 4, 5, 6. No, there are total 8 sides only. That's from the chapter lines and angles. Now draw all diagonals of the given polygon. Look carefully. There you have, no, that's the figure, Habib.
Okay.
Look carefully.
Yes.
Hmm. Okay. So total, how many I have drawn as of now? 1, 2, 3, 4. 1, 2, 3, and 4 as of now. Right?
Yes.
4. Then there's going to be more. Look, everyone. Everyone had done a mistake in this. Nafis and Laksh, you guys also. One more we have got. Another. One more. And then one more. So 4 plus 4, that is now 8. But is that all? No. You will be having few more in it. Okay, now let me zoom it out. Will these 2 points also not be connected? It will be now. 1, then we are having one more, 2. Getting it or not? Then you'll be connecting these also, right? That will also be connected. So now we are having 1, 2, 3 more, right? So how many have we got so far? 4 plus 4, 7, 7 plus 3, that is 10. Getting it? That is 10. Are there any more possibilities here? So yes,
Yes,
there's
sir.
more possibility. This one also here, isn't it? This one also. Getting it? Actually, no, it will be easier if you were to draw all the possible diagonals in separate diagrams here. It would be much easier to look at. So if you were to count the yellow ones, how many are there? Look, there's total of 1, 2,
4.
3, 4. No, actually 5.
Oh yeah, 5.
5, no? 5 plus 4 plus 4, that's 13. But again, is that all? No. There's going to be more now.
Yes.
These two can also be connected now. Yes or no? We can connect these two also. Getting it, guys? One more, right? One more. So there are so many different diagonals possible in it, no? Right now, there's going to be so many more. Now it's looking a bit complex, but still let's try to count the yellow ones. Look at it once again. So that is equal to 1,